This is Arizona. On the surface, it looks like nothing more than desert. But right here, one of the most important battles of the AI era is taking place. This is not just a showdown between Intel, TSMC, and Samsung. It is a race to control the thing behind nearly every critical technology in the world today: chips. From ChatGPT, self-driving cars, and robots to cloud computing and national defense, everything depends on chips that are becoming more powerful, smaller, and harder to manufacture than ever before. And the United States is entering a pivotal moment. Intel is betting its future on 18A, its most ambitious chip technology in years. At the same time, TSMC is building an unprecedented advanced chip manufacturing ecosystem on US soil. But the biggest question is not just who gets there first, it is who can actually make the world's most advanced chips at industrial scale. Because behind every breakthrough lies one cold reality. Advanced chip manufacturing is far harder than most of the world ever imagined. For years, the global tech industry has operated under a dangerous paradox. The United States leads in chip design, design software, and many core technologies. But large-scale advanced chip manufacturing, the hardest, most expensive, and most important part, has been concentrated mainly in Asia, especially Taiwan. That means the global digital economy rests on a fragile supply chain. A geopolitical crisis, a natural disaster, or even a major shipping disruption could shake the entire modern AI and computing system. That is why Arizona matters. A place once known mainly as desert is now turning into a strategic stronghold in America's effort to regain advanced chip manufacturing capacity. And at the center of that bet is Intel 18A. 18A is not important just because it is a new node. It matters because Intel is trying to change several core foundations of the semiconductor industry all at once. First, there is RibbonFET. As FinFET approaches its physical limits, Intel is moving to a gate-all-around architecture to improve current control, reduce leakage, and keep shrinking transistors. Next is PowerVia. Instead of forcing signal wires and power delivery to compete for space on the same side of the chip, as the industry has done for decades, Intel separates them. Signals stay on the front side, while power is delivered from the back side of the wafer. This reduces power loss, lowers interference, and frees up more space for logic. And that is not all. Intel is also the first company to bring high-end AEUV into manufacturing, a major step forward in lithography that allows even smaller features to be printed and transistor density to increase even further. If these technologies perform the way Intel hopes, 18A will not be just another upgrade. It could be a turning point that reshapes the global chip race. Why does that matter? Because AI is not just software. AI runs on compute, and compute is determined by chips. The more powerful and efficient chips become, especially in handling heat, power, and signal integrity, the larger AI models can grow, the faster devices can run, the more efficient data centers can become, and the lower computing costs can go. In simple terms, chips are the physical foundation of the AI economy. Whoever leads at this foundational layer will not just sell hardware. They will gain an edge in technology, industry, economic growth, and even global strategic power. But here's the most important part. Many people think mastering chips simply means building a very large factory. The reality is far more brutal. An advanced fab is not just a building, it's an extremely complex manufacturing ecosystem where almost everything must be nearly perfect. You need ultra-pure water, you need extremely clean air, you need ultra-pure chemicals, rare gases, wafers, measurement systems, highly skilled engineers, maintenance teams, stable electricity, and a supply chain that can operate with almost no mistakes. If even one part of that system falls out of sync, yield can drop sharply. And when yield drops, a fab stops making money. It starts burning cash. That is the first warning. Advanced chips are not just a game of money or technology, they are a game of ecosystems. TSMC in Arizona has exposed a truth the chip industry can no longer ignore. Building an advanced fab does not mean you can simply copy the Taiwan model, move it to the United States, and expect it to run the same way. On paper, it may look like just rebuilding a factory, but in reality, chip manufacturing has never been that simple. Once a fab begins operating, nearly every variable changes. Water supply, air quality, geology, suppliers, workforce, and even work culture. First, there is water. A fab does not just consume huge amounts of water, it needs ultra-pure water, so clean that even a tiny impurity can ruin an entire wafer. Then there is air. In a dusty desert environment, the clean room still has to maintain near-perfect cleanliness because even a tiny particle can disrupt the process, and behind all of that is the supply chain. Many materials, chemicals, and specialty gases still need to come from abroad. Even if chips are manufactured in the US, some advanced packaging steps still depend on Asia. That is the big lesson from TSMC Arizona. Having a factory does not automatically mean having full manufacturing capability, and having a fab does not automatically mean supply chain independence. This is where Intel's story becomes truly interesting. From a technology standpoint, Intel has reasons to be confident. 18A, ribbon FET, PowerVia, and high-NA EUV are all highly significant advances. The company has also begun bringing its first chips, such as Panther Lake, to market. But in semiconductors, being first does not guarantee victory. The deciding factor is not just technology, it is yield. High yield means the fab can make money. Low yield means costs rise quickly and the entire business equation becomes much harsher. But that is still not the whole problem. The rest comes down to customer trust. TSMC has a major advantage. It does not compete directly with its foundry customers. Intel is different. It wants to manufacture chips for customers while also selling its own products that compete with many of those same companies. That means many customers are still not fully comfortable. Has NVIDIA experimented with Intel? Yes, but that also reflects a bigger reality. AI demand is exploding, while TSMC's advanced chip capacity is becoming increasingly tight. The market does not want to bet everything on just one option. And that leads to the next warning. Strong technology alone is not enough. You also need yield, customers, capacity, and, above all, market trust. Seen from a wider angle, this is no longer just a story about Intel or TSMC. It is a story about who will control the core infrastructure of the AI era. The world is entering a period in which compute is becoming a strategic resource, but compute does not appear out of nowhere. It has to move through one of the most complex industrial chains in the world, from design and manufacturing to packaging, power delivery, cooling, and large-scale operation. The good news is that the United States is genuinely moving forward. TSMC has shown that advanced chips can, in fact, be manufactured on American soil. Intel has shown that it still has the ability to make a technological leap big enough to get the entire industry's attention. But the bad news is that there are no shortcuts in this race. You cannot rebuild the chip industry with a single law, you cannot do it with just one new fab, and you cannot do it with just one advanced EUV machine. To go the distance, you need more than that. You need talent, you need supply chains, you need packaging capability, you need power infrastructure, you need construction speed, and you need an industrial culture strong enough to handle the near-perfect precision this industry demands. So this is how I see the whole story. Huge chip breakthrough? Yes, absolutely. Intel 18A is a very significant step forward. TSMC Arizona is also a major strategic milestone. Big warning for everyone? Also, yes, because in the AI era, power will not belong to the company with the most impressive demo. It will belong to the one that can turn technology, supply chains, people, capital, and manufacturing capability into a stable machine that runs reliably at massive scale. And that is where the real battle truly begins. If you found this video helpful, please subscribe so you do not miss the next ones. Share it so more people can learn about this story, and hit like to support the channel. Thank you for staying with me until the end. Wishing you peace and happiness.